Welcome, KCSE 2026 candidates. I want to take you through practical. You need to start preparing earlier because if you wait until September, that's the time you want to start running helter-skelter, then you will find things difficult. My name is Teacher David. I want to take you through chemistry paper 3 because I understand how important paper 3 papers are. I understand how important paper 3 papers are. Paper 3 papers, whether it is physics, chemistry, or biology, it carries 50% of what you will score, 50%. And the paper 1, paper 2 share the other 50%. So paper 3, it has 3 portions, or it has been categorized into 3 parts. Number 1, we have qualitative analysis. Qualitative analysis has got 2 parts. Number 1, we have organic analysis. Number 2, we have inorganic analysis. Then number 2, we have quantitative analysis. Now, quantitative analysis is where we do the mole, the graphs. That one is called quantitative. Now today, I want first to start by taking you through qualitative analysis, where we will do the organic and inorganic part of it. So I want to take you through that. Follow, share, subscribe. Remember to share to WhatsApp group. You copy the link and then share. Thank you very much. So let's look at this question. You are provided with solid R. Carry out the following tests and write your observations and inferences in the spaces provided. Place ore of solid R in a boiling tube. Add about 10 centimeters cube of distilled water. Shake thoroughly. The observation is the solid dissolves to form a colorless solution. So when a solid you are provided with dissolves to form a colorless solution, we know very many ions which are colorless: sodium, potassium, magnesium, calcium, zinc, barium, lead. All those are colorless. They form a colorless solution when they dissolve. So here we want a candidate to tell us that in this solution there is no copper, which is blue. There is no ion 2, which is brown, ion 2, which is green, and there is no ion 3, which is brown. So that is, initially we used to say students could write, if it dissolves like this, a student would write soluble solid present, soluble substance. Sometimes that kind of thing is not marked. It is ignored. So it is important, if it is dissolved to form a colorless solution, then write, we can start with, we call it kufefe. For you to remember, we call it kufefe. Right? So remember with the word kufefe. So kufefe stands for copper ions. This is capital C, copper 2 ions, then ion 2 positive, then ion 3 positive, then this one is absent. This word absent is very important. So these 3, this is what we are testing when we ask you to dissolve this solid in distilled water. So if it forms a colorless solution, colorless, it means the colored ions are absent. Copper is blue, ion 2 green, ion 3 brown. They are absent. Very good. Divide the mixture in A above into 5 portions of almost equal volumes and carry out the following tests. To the first portion, add to the first portion, add 2 molar sodium hydroxide solution dropwise until in excess. So sodium, then when you're adding sodium as a reagent, you expect 3 observations. Number 1, a white precipitate which dissolves in excess. Number 2, a white precipitate which does not dissolve in excess. And number 3, no white precipitate. So these are the 3 observations you expect when you are using sodium hydroxide as a reagent. And each observation has got its own answers in the inference side. So for this one, a white precipitate, then this white precipitate in drops, when you are told dropwise until in excess, it means you add 2 drops first, observe what is happening, then add more so that is in excess. A white precipitate is formed when you add 2 drops or 3. Then in excess, the white precipitate dissolves to form a colorless solution, and you are using sodium hydroxide as the reagent. Then if that is the case, then what is present is what we call ZAP. So ZAP is what is going to help you to remember when you are adding sodium hydroxide, a white precipitate is formed, and that white precipitate dissolves to form a colorless solution. Then ZAP is present. What is ZAP? ZAP stands for zinc 2 ions, aluminium 3 positive, and lead 2 positive. So this one, if that is there, it means they are present. It means they are present. Okay. So as we revise, I will tell you now next, if a white precipitate is dissolved insoluble, what are you supposed to write? No white precipitate, what are you supposed to write? So let's finish this so that you don't get confused. So master that if a white precipitate is formed soluble in excess, which dissolve in excess, then this is the answer. Let's move to the next one. So we have said these 3 ions are present. Do the second portion add 2 to 3 drops of sodium carbonate. So sodium carbonate, we remember, for you to understand this solubility and this qualitative analysis, you need to understand the solubility very well from 2 work. You need to know that all sulfates are soluble except lead sulfate, barium sulfate, calcium sulfate. You need to understand that all chlorides are soluble. They form a colorless solution except lead chloride, but lead chloride is soluble when you warm. Then silver chloride. These are the things you need to know. Another thing you need to know is that we have talked about sulfates and then carbonates. All carbonates are insoluble. They form a white precipitate, right? All carbonates are insoluble. And they form a white precipitate except the carbonate of sodium, the carbonate of potassium, and the carbonate of ammonium. And you need to know, very important, that there is no carbonate for aluminium. Aluminium carbonate does not exist. These are the very important things you need to know, as you can see. Let's look at this question now. The second portion, add 2 to 3 drops of sodium carbonate. Sodium carbonate is a colorless solution. Then when you add, a white precipitate is formed. So from what we had initially, we said zinc is present, aluminium is present, lead is present. What could form a white precipitate with zinc, with the sodium carbonate? Now, what is important here is the carbonate, not sodium, because these are metals. A metal and a metal cannot join, cannot combine. So the most important here is the carbonate, right? Now, this carbonate will combine with zinc to form zinc carbonate, which is a white precipitate. Aluminium carbonate does not exist, so it is not there. Therefore, lead carbonate is a white precipitate because we have said all carbonates are insoluble, meaning they form a white precipitate except carbonate of sodium, carbonate of ammonium, ion, and carbonate of potassium. The rest are white precipitates. So it means that aluminium now is not is absent here. If aluminium is absent, we had 3, and we have now confirmed here, if a white precipitate is formed, then what is there is zinc, 2 ions, lead, 2 ions. Mbona tumesema aluminium haiko? Aluminium carbonate does not exist. That is the knowledge you need to have. So we have eliminated aluminium up to that point. That is the knowledge. Now, zinc carbonate is a white precipitate, lead carbonate is a white precipitate from the knowledge of solubility. All carbonates are, all of them are, all metals are, metal carbonates are insoluble. They form a white precipitate except the 3 I have mentioned. But the aluminum carbonate does not exist. To the third portion, add 2 to 3 drops of sodium sulfate. Now we have sodium sulfate. In sodium sulfate, we are not interested with this metal because these are metals. Zinc is a metal that we have said is present. Sorry, I did not write here present. It is important you write this is what is present because the word present and absent is very important in qualitative analysis. Now, we are not interested with the sodium. The sulfate, because these are metals, we expect them to react with the negative ion since these one are positively charged. Now, we added sodium sulfate and there was no white precipitate. Obviously, a white precipitate is, if this sodium sulfate finds lead in that test tube, a white precipitate is going to be formed. Since there was no white precipitate, it means it is a zinc 2 positive that is present. Meaning a lead is absent. Why? If lead was present, a white precipitate was supposed to be formed because lead sulfate is a white precipitate. We said all sulfates are or form a white are soluble. All sulfates are soluble except the sulfate of barium, the sulfate of lead, and the sulfate of calcium. Now, if there is no white PPT, as you can see here, there is no white PPT, it means lead is absent, meaning otherwise it could have formed a white precipitate with the sulfate here. I hope that one is correct, it's clear. Now, if this is zinc, remember we don't write what is absent, we write what is present. Major. It is only in a few cases where there is no option, we write whatever that is absent, right? But if there is something which is present and another one is absent, always write the one that is present. Leave alone the one that is absent. To the fourth portion, add 2 to 3 drops of silver 2 nitrate. Silver 2 nitrate, followed by 2 drops of dilute nitric acid, no white precipitate. So if no white precipitate, silver will form a white precipitate with chloride ion only, Cl. So because I've said all chlorides are soluble except silver chloride and lead chloride. Because we have said, now this we are testing for now for the anions. It means the chloride ion is absent. If it was present, it could have formed a white precipitate with silver, so that we have silver plus chlorine, it will form silver chloride, which is a white precipitate. But here, no white precipitate. That is the key. To the last portion, add 2 to 3 drops of barium nitrate solution, followed by 2 to 3 drops of dilute nitric acid. Now, here, barium forms a white precipitate with 3 ions, with 3 anions. That is the sulfate, the carbonate, and the sulfite. So if a white PPT is formed, then it means this and this and this are present. That is where we add 2 to 3 So a white precipitate, when we add 2 to 3 drops of barium nitrate, the white precipitate is formed. It is because these three are present. Now, followed by 2 to 3 drops of dilute nitric acid. If inside here there was a carbonate, so we will have barium carbonate. So barium carbonate will dissolve in dilute nitric acid. If we have barium sulfite with 3, it will dissolve in this acid to form a colorless solution. But if it is sulfate, it will not dissolve. So since we are adding 2 drops and then followed by dilute nitric acid, and what remains is a white precipitate, then it confirms it is the sulfate that is present. These two are absent. Why? If they were present, if it is the carbonate or the sulfite that was present, it will dissolve to form the white precipitate that was formed with 2-3 drops of barium nitrate will dissolve in the nitric acid to form a colorless solution. But now, since there was no colorless solution, it is the sulfate that is present. Very important. If you don't get that, always consult. You can always reach out 0726 468915 to assist you on WhatsApp. You can WhatsApp and I will be able to assist you where you are getting stuck. Now what we have done is inorganic analysis. Now we are entering to organic analysis, and if you have seen my video, and if you have not seen, we use the reagents to know whether this one is organic and this one is inorganic. We use the reagents. So how do you determine that this one is organic and this one is inorganic? Where you see barium nitrate, you see silver nitrate, you see sodium sulfate, you see sodium hydroxide, sodium carbonate. Sodium carbonate can be used in both, but there are those that are very distinctive that differentiate. Sodium hydroxide. To always remember, when you see sodium sulfate, you are dealing with inorganic analysis. Where you see bromine, you see acidified potassium permanganate. That one can be in both cases. But the one that differentiates that is when you see bromine water, which one? Then you burn the solid, then it burns with blue, non-soot, all those. Now those are the things which show you that you are dealing with organic analysis. Now you have been given the solid M, place about a third of that in spatula, then you heat. So the solid melts and burns with a yellow smoky flame. So you can either use this one or you don't use. So here you say the solid melts and burns with a yellow sooty means smoky, sooty flame. You can use one word there. So if it burns like that, it means then this is an organic compound. We suspect it to be an organic compound, and it is a triple bond or a double bond, because these are the ones that are unsaturated. Therefore, this is a double bond or it could be a triple bond. An alkane, an alkene, or an alkyne. An alkene, an alkyne is present. Remember, this carbon must be surrounded with 4 covalent bonds. If you don't surround it with 4 covalent bonds like this, you get nothing. So it must be surrounded with 4 covalent bonds this way. So it is present. Now we move on. Dissolve all the remaining solid M in the distilled water. Then the solid dissolve to form a colorless solution. Now we know we are dealing with organic. Here, do not come back here to tell us that the colored ions are absent. Copper, iron 2, and these are absent. That is wrong. Since we have identified that we are dealing with organic analysis, we don't try to cut ions on the other side. There, we don't have ions at all. Therefore, if you have already identified that we are dealing with organic analysis, you have dissolved the solid and it dissolves to form a colorless solution. It only means one thing. It means that that solid is polar. Only that. It means the solid is polar. If it does not dissolve to form a color, it means it is non-polar. Full stop. There's nothing more, nothing less. Remember, that's why it is important for you to know that you are dealing with organic or inorganic. Do not write here, kufefe absent. You will not score anything. To the first portion, add acidified potassium permanganate. Acidified potassium permanganate is purple in color. Is purple. So if acidified potassium decoloralizes, that is, the color changes from purple to colorless, it means three things are present: the double bond, triple bond, and alcohol. That is for acidified potassium permanganate. So it means the double bond. Check the way I'm surrounding the carbon with 4 covalent bonds. This carbon must be surrounded 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. This is a comma. This is a comma. 1, 2, 3, 4. Or ROH. ROH stands for alcohols. So these are the three that are present whenever we are testing for potassium permanganate. These three are either present or absent. If the color did not change, remains purple, it means 1, 2, 3, absent. Keyword is present, absent. To the second portion, add sodium carbonate. Whenever we are adding sodium carbonate and we are dealing with organic, we expect effervescence. Effervescence ni venye unafungua soda, Coca-Cola, inakula kuchemuka ndio inaitwa effervescence. So effervescence occurs, that's one way, or you can say bubbles of a colorless gas are formed. Don't write this or, you choose one and use it. If that is the case, then it means that if this is a carbonate, you are adding into a solution in the test tube and effervescence it occurs, then it means that solution that inside there could be an acid, a weak acid, or a strong acid, depends. So if effervescence occurs, then it means there is an acid. Now, either the answer is supposed to be RCOOH, standing for organic acid, that is like methanoic acid, propanoic acid, or there is an hydrogen ion so present. This one stands for acids. Now, which one are you going to put here? It depends on the question. Now, let's go back to the question. You need to be careful here. If the question here said you are provided with organic solid M, if the question says you are provided with organic solid M, then the answer should be this. You get that? The answer should be this. But since the question did not tell us whether it was organic, although we know we are doing, it did not say. So because it did not specify, we have H positive present. Do not use this now. Don't use that one. It is this one that is present. This one, we use it when the root of the question is specific. You have been provided with an organic compound solid, whatever. Very good. To the third portion, dip a universal indicator, then you will be given the pH scale. You will check and balance with, you will be given the pH, you know your pH, the paper, which has the colors from 1 to 14, and you have your solution in the test tube, which has got a certain color after you add the universal indicator. Then now you will compare and see this thing that you have in a test tube. How does it compare? Which color is comparing here? You see that? Now, after that, you will see, for my case, the color was red. then that indicates that the pH is 2, and if the pH is 2, that is a very strong acid. You simply write here, strongly acidic. So if the pH is 1, 2, 3, you say strongly acidic. If the pH is 4, 5, 6, you say weakly acidic. Weakly acidic. I don't know whether this is the correct spellings, or there is no I, whichever. Weakly acidic, right? Yeah. So remember to share, subscribe, and always follow here. If you need, there is an app I have which will enable you to get all the videos that are in my channel. If you need the app, my number, I've given it up there. You can text WhatsApp, I send you the app so that you can install to your phone and make sure you use it. It will be helpful. Remember to share this work. Thank you, very important.